Hello student, in this video we'll talk about what is the difference between balanced force and unbalanced force. Okay, or we can say when the forces will get balanced or it will get unbalanced. But before going to this main topic, here we have to discuss about a small thing that is called as what? Resultant force. Resultant force. What is resultant force? Now, first thing is that whether force is scalar or that is vector. Yes, force is a vector quantity. Okay, so force is a vector quantity, and we all know what is a vector is. Okay, what is a vector? Vector is that which is having magnitude as well as the direction. So that means force is coming under the vector. That means it is having a magnitude as well as direction. Okay, so this is one aspect of this force. That means it is a vector quantity. Now the second thing I'll discuss here, if we are taking about vector quantities, right? How the vectors get added. How the vectors get added. Are they added like the normal algebraic mode of addition? No. Scalars can be added by algebraic mode of addition. What is the meaning of this one? Let's suppose I am taking 2 meter length of wire. Now I tied it with another wire of 3 meter length. Now what is the total length of this wire? Now total length will be equals to what? 5 meter. So this is what? This is the algebraic mode of addition. So that means length. We are discussing about length. What is that? Length. Length is a scalar quantity. It is only having magnitude. So that's why when we are adding them, okay, so that time we are simply go by algebraic mode of addition. This is called as algebraic mode. Algebraic mode of addition. Okay. But why we talk about vectors? Vectors cannot be added like this. Okay. So vectors are added vectorially. And how it will be added? So that I will not discuss because it is not under your topic. So you will study it in class 11. So don't ask, don't think of that one now, right? Now only we should know that vectors cannot be added in algebraic method. So that I can write here, vectors cannot be added by algebraic method. Okay, so we understood these 3 points. First point I need to say you is force is a vector. Yes, force is a vector quantity. Second point I said what? Scalars added. So this is scalars. So scalar quantities can be added by algebraic mode of addition, whereas vectors cannot be added by algebraic mode of addition. Okay, so they will be added by geometric method. Okay, or that is called as vector addition method. So that need to be followed. Okay, now this is the basic 3 things we should know. So I know about this force. Now we'll discuss what is resultant force. Now the resultant force in the sense, if a number of forces acting on a body simultaneously then the net force is called the resultant force. The net force is called as the resultant force. So that means if suppose on a body, suppose this is a body, on this body a number of forces are acting. Okay, suppose this is one force, suppose this is another force, suppose this is another force. So like that a number of forces are acting on the body. Then when we have to find what is the net force acting on that body, we can take the net force. F will be equals to what? That is in vector form if you look at. So this is F1 vector plus F2 vector plus F3 vector. So that means we will add them by the vector method of addition. Anyway, so that means after adding what is the what result you are getting, that is called as your net force, and that net force is actually called as your resultant force. So don't go for this one. This is not required now. But the meaning is that what I said, that resultant force in the sense when a number of forces are acting on a body, then the net force which is acting, which will be calculated after adding vectorially, that net force is called as what? The resultant force. Okay. So you understood what is resultant force? So resultant force is the net force acting, okay, when a number of forces are acting on a body. So that net force, how to calculate? So that it's not in your that syllabus, but simple methods are there, the simple calculations are there where you can calculate the net force. That will talk. Okay, so this is what resultant force is. Now we'll see about what is balanced force now. Now what is balanced force? So here we write, if the resultant of all the forces acting on a body is 0, then the forces are said to be balanced force. Okay, so this is important what I said. If the resultant of all the forces acting is how much? It should act, means its value should be what? That is 0. So let's take an example to have a clear knowledge about what is that resultant is 0. So I have taken a body, let's suppose here, and on the right side of this body, let's suppose 10 Newton force is acting. And let this is force F1, which is 10 Newton, which is acting towards right. Another force is acting towards left, and this is force F2. This is also 10 Newton. Right? Now if I ask what is the resultant force is acting? Resultant force in the sense what I said, the net force, and the resultant force is equals to F1 plus F2. But here I said you it cannot be added like what? Scalar method of addition or algebraic method. I cannot write 10 plus 10 equals to 20. Okay. So here what will be the result you see? Since force is a vector, I said it is always depending upon the direction. If it is depending upon the direction, now here the 10, here F1 value is written 10, that is actually magnitude of that force 1. And similarly this 10 Newton is the magnitude of force 2. Now what is the direction? How I can show that direction? I will show the direction by the sign convention. So how to show the sign convention? Your normal method of sign convention you can follow. Let's suppose this is the origin that you might have done the graph. Okay, so in that case what we have to take, this is your y-axis, this side is your x-axis, this is the origin. Now origin to the right while you go, you take positive side. While you go from origin to the left, that side is taken as what? Negative. The same pattern here also will follow. Now this 10 Newton F1 is actually the positive side, so this can be taken as plus 10 Newton. And this 10 Newton which is in the left side, this can be taken as what? Minus 10 Newton. Okay, now we'll find the resultant force. Now this will be equals to F1 is plus 10 minus F2 equals to 10 minus 10. Now what will be the net? 10 minus 10. Yeah, so what happened here? What is the result? Now this is giving you 0. This is called as 0 resultant. What is 0 resultant? Here we have seen, though there are two forces are acting simultaneously, but the net force when we calculate, that is giving you the 0 result. Then this is the case where we can say the body is balanced under these two balanced forces. Okay, so that means here you can see, though there are two forces are acting on this body, but the resultant is coming 0. Is there any change in the state of the body? No, there will be no change in the state of the body because there is no forces acting here. Though two forces are acting simultaneously, the result is giving you 0. So in that sense, what I can say here, that the body is now balanced. It's not going to change its state. If it is at rest, then it will continue to be at the same state of rest. If it is in the state of uniform motion, it will continue to be in the same uniform motion along the same line. Okay, then you can say the body is under the balanced forces. Okay, so that means this example what we have said, this will give you another definition for this balanced forces. So let's see what is that another definition. Okay, see what I have written here. When a number of forces acting simultaneously on an object do not bring any change in its state of rest or state of uniform motion along a straight line, then forces are said to be balanced forces. Okay, so what I said here, when a number of forces acting simultaneously on an object do not bring, so that is an important, okay, do not bring any change in its state of rest. That what we have seen in the previous example. What I said, when there is a net force acting is 0, or you can say the 0 resultant is acting, that time what, there was no change in its state of rest or in uniform motion, then this will be called as what, these forces are called as what, balanced forces. Okay, now we understood what is balanced force. Let's talk about the second kind of force, which is called as unbalanced force. So let's discuss about the unbalanced force. Okay, so here I'll write this is unbalanced force. So let's discuss about unbalanced force. So when we can say forces are said to be unbalanced? Now according to the definition, if the resultant of number of forces acting simultaneously on a body give non-zero resultant, then the forces are said to be unbalanced force. Unbalanced forces, right? So what I said here you can see this is important. If the resultant of number of forces acting on a body gives what, non-zero resultant. Now let's take an example for this. So same thing I have taken, this is a body. Let's suppose the force acting in this side F1 and its magnitude is, let's suppose this is 20 Newton. And to the left, let the force acting is F2 and its magnitude is 15 Newton. Okay, and as the sign convention what we have discussed, towards right, so this will be plus sign, towards left it will be given a minus sign. Now when I'll find what is the resultant force acting here, so resultant force will be equals to sum total of these two forces, F1 plus F2. What is F1 value? That is plus 20. What is F2 value? That is minus 15. Now what is the value? 20 minus 15 is 5. So 5 Newton is the resultant force. Okay, so here we can see that the magnitude of the resultant force is not coming to be 0, but it is a non-zero digit we got. Then in that case we can say the body is not under what balanced force, but it is unbalanced force. Okay, look at here, that 5 Newton what we got, that is the magnitude of the resultant force here. Now what will be the direction? That is important. What will be the direction of that resultant force? So always remember the direction will act towards the what? The force which is having greater magnitude. So that means here if we will compare F1 and F2, whose magnitude is greater? This magnitude is greater. Don't look at the signs, only look at the magnitude. Here it is 20, here it is 15. So out of this 20 and 15, which is a greater magnitude, so 20. So that's why the resultant will act in this direction. And this is the right, so I'll write towards right. Towards right. If this side would be more than that side, then in that case the resultant would have what? Towards left. So that's why, so resultant depends upon the higher magnitude's direction, and that will be the resultant's direction. So that means here we discussed what? That means here when a number of forces acting and the result is not 0, in that case there is some net force is acting on the body. Some resultant force is still acting on the body. And if there is a net force acting on the body, in that case the body state is going to change. Like the previous case, since 0 resultant is acting, that's why the state was not going to change. But in this case, since there is some force is acting, some net force is acting on this body, so that means the body state is going to change. That means if the body is in the state of rest, it will not continue in the same state, but the state will convert to motion. Similarly, if it is in the state of uniform motion, it may come to stop also. So that means state is going to change. Even the direction also change due to this net force. So that means here we will get another definition for this unbalanced force. When a number of forces acting simultaneously on a body bring about a change in its state of rest or of uniform motion or direction, then the forces are said to be unbalanced forces. Okay, so what I said here, when a number of forces acting simultaneously on a body, so that is more important, it brings about a change. It brings about a change. We have seen that when there is a net force acting on the body, so in that case what? There is some changes take place. So that's what it is written. It brings about a change in its state of rest or uniform motion or direction. That means in that case what? The state of rest changes. Even the state of motion also gets changed. Even the direction also can get changed due to this net force. Then in that case this force is termed as, or the forces which are acting, they are termed as unbalanced forces. Okay, so that means you must be clear about what is balanced force, what is unbalanced force, what is the difference between them.